so here we're going to talk about radians. Okay, I'm going to talk about a couple of different things. I'm going to show you what my expectation is, but you know my teaching style is to make sure you understand why is it that we're doing what we're doing. Okay, I can't just, here's what to do, and this is what I want you to know. I want you to have a better understanding. For those of you who are going the pre-cal route, and you're going to get into pre-calculus, you will spend several weeks, like several units on the unit circle. Okay? Do you know at the beginning of the year when you came in and I said something about Pythagorean theorem, some of you were like, oh, I remember something about that. You may not have remembered how to work it, but you had something in your brain that was like, I remember something about that. Or after Christmas, we talked about transformations, and you had some already pre-knowledge about transformations, right? Okay, that was helpful, wasn't it? Well, I'm about to give some of you some pre-knowledge that I hope you carry with you into that pre-cal class. Okay? So I'm going to give you some pre-knowledge. I want you to think about it. You may not fully understand what I'm talking about today, but I want you to see it and know that it all fits together with pieces. Are we good? I'll show you and say, this is what I expect you to understand. But I'm going to show you where it comes from, so it'll make a little bit more sense. Okay, do you remember when we did the trig unit, I had you take your calculator and put it in a certain mode? What mode did we put it in? Degrees. What's the other mode? Radians. So today we're talking about radians. Radians is nothing more than the measurement of the radius using the central angles. Okay, so we're talking about circles. We're talking about those central angles. Okay, all the way around a circle, that's the circumference, right? Remind me, what's the formula for circumference?
2 pi r.
2 pi r. What we're talking about today is what we're going to call the unit circle. And it's called the unit circle because I want the radius to equal 1 unit. So if I go to find the circumference of this circle, I'm just going to plug in the r right here. Well, what's 2 times 1? 2. So the circle we're talking about today has a circumference of 2 pi. Are we good? All right. So I'm going to take a step back, and we're going to talk about a circle. And I'm going to start at 0. Okay? How many degrees do I go if I go up to here? 90 degrees. Everybody with me so far? And then I go over here. How many degrees would it be over here? 180. And what would it be down here? 270. And then I go back over here, it would be what? 360. So this number right here is 0 and 360. Are we okay? Now, a couple of units ago, we talked about 30, 60, 90 triangles and 45, 45, 90 triangles, correct? There's a connection here. I'm getting there. Okay, I'm going to take it baby steps. So I can count by 30s here. 30, 60, 90. What comes after 90? 120. 150. 180. What's next? 210.
240.
240. 270.
310.
300.
340.
And 330. Are we good? Are we okay? Alright, that's part of it. It's okay. Okay. Then we have our 45, 45, 90 triangles, correct? So now I can count by 45. We have 0. Right here would be 45. Everybody agree? Then 90. What comes next? 135. Then 180. What's this one? 225. Is that right? Good. And then we have 270. And then we have 315. And then back to 0 again. Okay, does everybody understand? I just put the degrees on here, correct? But I made it connections that we had talked about 30, 60 triangles and 45, 45 triangles. Are we good? Okay, then what I just told you back over here is that if we're dealing with a unit circle, we have circumference, and my radius is 1, so my circumference is going to be 2 pi. So if I'm looking at this picture, and I start here and I go all the way around, what would be this number? Careful, I'm talking now radians. So what's my circumference? 2 pi. Are you with me? So if I'm looking at this circle and I start here and I go all the way around, this number in radians is 2 pi. It's 0 and then starts at 2 pi, right? So what if I started at 0 and I went to here? What would I have? Well, if this is 2 pi, right? This is 0 and 2 pi? So this would just be pi, wouldn't it? What would this number right here be? 0.5, right? Or pi over 2? Pi cut in half? So this is from here, I go half pi, pi, and what's down here then? 1.5 pi, 1.5 pi, right? How can I write 1.5 as an improper fraction?
2/1.
Well, then it's 2 times 1 plus 1, 3 over 2 pi. Are we okay? And then this would be 2 pi. Okay, I know that was a little bit of a struggle, but you kind of have an idea what I just did, didn't you? Do you? Okay. So now we're going to come back over here. And we're going to talk. What I want you to comprehend today before you walk out is how to convert radians to degrees and degrees to radians. Okay? I don't expect you to understand that whole circle thing and what we just talked about. That's just a guide to help you. What is it that we're doing? Are we okay? Everybody with me? Not really? Okay.
Right.
All right, so here's what I want to make sure you understand. Is if we go from degrees to radians. So my first problem is they want me to convert 120 degrees to radians. All you have to do is multiply by pi over 180. That's all you have to do. That's all I want you to fully understand. Okay? So right here, this is 120. And we're going to multiply that by pi over 180. So 120 times pi is 120 pi. And that's over 180. So in your calculator, I want you to push 120 divided by 180, math, enter, enter. In your calculator, you're pushing 120 divided by 180, math, enter, enter. And tell me, what do you get? 2/3. We just now converted this problem, and the answer is going to be 2/3, but I can't just leave off that pi symbol, so it's 2/3 pi.
Can you take me through the steps of how you divide it together?
Yeah, on your calculator, push 120 divided by 180, math, which is underneath the second key, enter, enter. Okay, I want you to try number 3. I want you to try number 3. Okay, so here we did 270, and I want to go to radians, so we're going to multiply by pi over 180. Everybody good? And so if I multiplied straight across, you had 270 over 180 pi. Everybody agree? And then when you reduce this down, it was 3 over 2 pi. Is that true?
Yes.
How many of you had that as your answer? Good. We already did this. Are you watching? It's 270, and you say the answer is 3 over 2 pi. Look here. On our circle. At 270, what did we say the answer was going to be? 3 over 2 pi. Do you remember how we got there? Because we said if this is 2 pi, when I got to 90, that's half of a pi. Over here is 1 pi. Miss Ramsey, why are we using pi and 180? Because 1 pi is 180 degrees on the circle. Are we okay? Do you kind of see that little connection there to understand that where these numbers are coming from? It's not Miss Ramsey just making something up and throwing it out there. Are we okay? So 270 is 3 over 2 pi. Okay, let's go back. Now I need to say, well, what happens if I want to change it to degrees? Okay. Now if I want to go from radians to degrees, guess what? I take those same two numbers and I flip it. Whatever I want it to go to, that's what I put on top. Whatever I want to go to, that's what I put on top. So I'm not doing anything different. I'm just flipping and I'm trying to get from one to the other. So let's take a look at number 2. I want you to try number 2 real quick. Just you give it a shot in the dark. Let's try it. Number 2. We're converting from radians to degrees. So what goes on top? 180, right? The degrees. So if I have 2 pi over 3, and now I need to multiply that by 180 over pi, what's 2 times 180? 360. And I have this pi in there, don't I? And on the bottom, 3 times pi, well, that's just 3 pi. What happens with these pi's? They cancel out. And how many times does 3 go into 360? 120, right? Oh, well, I hope so. Because we just did the same problem one way and the other. See, we did from 120 to 2/3 pi. We did from 2/3 pi to 120, and we got the same answer. Are we okay? In just a minute, I'll show you why. I'm going to show you where this number, because this number right now to you means nothing, does it? Okay, I'm going to show you why here in a second. I want you to try number 4, though. I want you to try number 4. Take a second, do number 4 on your own. All right, let's see what you did. So we have pi over 6. What goes on top? 180 goes on top, right? So on the top here it's 180 pi. Then on the bottom it's 6 pi. What happens to the pi's? How many times does 6 go into 180?
30.
Oh, 30. 30 degrees. Huh. So Mr. Nancy, that's great and all, but I have no idea why it is we're doing this. Would you agree? Like, you kind of see a resemblance in that circle, but you're just not sure? Okay, so let's come back over here and let's make it a little more testy. Let's figure out what we're doing. Okay, how big is the radius? How big was my radius? Do you remember? 1. My radius was 1, remember? Okay, I can divide this if I count by 30s. Okay, I'm counting by 30s, aren't I? How many sections do I have? 6. So if I get to here, this is 1/6 of pi. This is 2/6 of pi. This is 3/6 of pi. Can I reduce 3/6 to 1/2?
Yeah.
I can. Okay. And then right here, this would be 4/6 of pi. 5/6 of pi. 6/6 of pi. Does that reduce to 1?
It does.
Okay. Oh, look. Didn't we talk about 30 a minute ago? That's wrong.
Degrees.
Wasn't it pi over 6? 1/6 of pi? Are we okay?
Yeah.
Okay. This 2/3 2/3 of pi is 120. Well, let's see what we got for 120. Oh, wait, it's 4 over 6. Can I reduce it? To what? To 2/3 of pi. Now do you have a little bit better understanding of what it's doing? Okay, question here. What if we counted by 45s? How many sections would I have? 4. So that means this is 1/4 of pi. This is 2/4 of pi. Can I reduce that down to 1/2? This would be 3/4 of pi. And this would be 4/4 of pi. Does that reduce down to 1?
Yes.
Now, I'm going to rock your world. It's okay, but I just want you to see this. Because this right here also relates to 30, 60, 90 triangles.
Yeah, I got the same.
You ready? Watching? So right here, I dropped down an altitude that's 90 degrees. Now I have a 30, 60, 90 triangle. My radius is 1. Remember the pattern is 2x, x, x radical 3. If my radius is 1, this side is 0.5, this side is 0.5 radical 3. Here I have a 45, 45, 90 triangle. Here I have a 30, 60, 90 triangle. It's just backwards, right? I come back over this way and I can do the same thing.
So weird.
But now what I have is just a reflection of that one. Now I have transformations within here. And I'm not even showing you how sine, cosine, and tangent fits in.
Oh my goodness.
It all goes together. It fits into the circle.
That's the
I know, but I just want you to see it all fits together.
Yeah, but I'm not. That's all.